Welcome everybody to this edition of X Live, coming from X-Blue's headquarters just here in Saint-Germain, just west of Paris. My name's David Cunningham. I'll be your sort of host for this event, and I'll be joined shortly by a colleague from one of our other factories in France, from Brest in Brittany. We're still a bit constrained with movements and so on in France, so we're maintaining this sort of remote construction of this webinar. So today we're going to be talking about our Delph geophysical software suite and trying to give some snapshots of the efficiency boosting features of that software suite. The format of the day it's probably about 25-30 minute presentation. We set up a series of movies to show different aspects of the software. The idea is to cover the whole story, but not in tremendously great depth. So if you want to know more at the end, then please don't hesitate to contact us on any specific points. And we will be running some future webinars on specific elements that we'll go into a little bit later on. So if you've got any questions which arise during the presentation, don't hesitate to post them on the webinar platform, and we'll answer them all at the end of the show or the presentation. Anyway, enough from me. Let's introduce Philippe Alain from our factory in Brest. Philippe is the geophysical products manager for X-Blue. Welcome, Philippe.
Good morning, David, and thank you everyone for joining this event. It will be a pleasure to present you the Delph software range today.
Okay, so what we'll do as a starting point, maybe Philippe, just give us a very brief introduction to the Delph software suite, where it's come from, who it's for, and so on.
Yeah, exactly. So Delph software is part of the X-Blue range of products and software. We have software for various products like positioning, inertial surface, etc. The Delph software that we'll talk about today is a geophysical software suite, which is devoted to the acquisition and processing of geophysical sensors, being seismic, sub-bottom, mag, side scan sonars. This comes from a long-running history from the past 30 years. We've been in the industry, so accompanying the changes in the workflows for our users. And today we'll present you how to optimize the data collection and the processing of the geophysical data. In two chapters, one part will be towards the surveyors and how to collect the raw records, and one part will be towards the hydrographers and geophysicists who will do QC data analysis, mapping, and interpretation of the complete project. So that will be the two aspects covered today.
Okay, so that's the brief overview. What as I said, we've prepared, or what Philippe and his team have prepared, as a series of sort of movies, which we'll run through slowly and describe the different elements of it, from on the acquisition and then the interpretation processing side. Maybe just start with a quick overview of the full software suite, Philippe, just to explain the different modules that are available.
Yeah, right. So you will see some mapping on screen right now. So this is a composition of the software suite. So there is a lot of different modules. The software is very modular, and it comes all from the data collection from the sensors, which you have on the bottom left, all the sensors and the data collection through what we call the Delph acquisition product, which is the first product of the range, leading to the raw data records. That's something that the geos will then work on throughout the Delph interpretation software, which is more the right-hand part of it. And they will find dedicated modules for filtering, improving the data for side scan, seismic, and magnetometers, and to quickly achieve maps, georeferenced results that they will display in the Delph roadmap software, which is not a product as such, but our core 3D visualization platform, which is a cartographic environment in 3D, where we go from the raw data to the process records, and we do the data management in here. So people can do QC, mapping, interpretation, and reporting of their surveys.
Okay, so that's the quick overview, the quick snapshot of the full software suite. And so we're going to focus initially on the acquisition side of life, and then later on the interpretation side of life. And during the small movies that we'll show you now, you'll also see the Delph roadmap, which is the 3D cartographic visualization module, which essentially links the two sides of the product suite. And so you'll see elements of the data appearing in that environment throughout the presentation. So let's move on, Philippe, to the acquisition side of life. And here's just the focus of the acquisition
Yeah, the drawing is very simple. We come from the sensors and the navigation data to the raw records. It's very essential in there to log only raw data, do not any pre-processing in there. Data collection from the navigation, proper timestamping, and using the standard industry formats, XTF, segwise, and so on. As you will see on screen, the software is composed of two sides in there. The real part of it, the Delph acquisition software, is the left-hand side, in which you will find the traditional real-time display of, in this case, the scrolling side scan data, signals, navigation repeaters. Also, what is key is this really simplified user interface, so very few commands, big indicators monitoring the data quality if you are acquiring, logging, and collecting the navigation safely. And so this is really what people want to monitor during the survey operations. In a second example, we will see a quite similar user interface, but in this case, for the sub-bottom profiler, right now on screen, yeah. So you will see the very same familiar user interface. In this case, it's sub-bottom profiler data. This comes from an ECOS 10,000, which is part of our range. Just behind of you, David, is this transducer that we are manufacturing in the sonar division in XBlue. And the right-hand side of the screen is the Delph roadmap software that you briefly talked about, which is our 3D cartographic software. So in this case, we are monitoring the real-time track plot, location of your vessel, your sensors within a familiar cartography, with the bathymetric surfaces, background coastal contours, background charts, anything you would like to see to correlate your acquisition data together with the maps. And of course, you can run the acquisition standalone, or you can accompany it with the roadmap software, which takes no configuration. So it's live data with in a very simple way.
Okay, so that's two very quick samples of acquisition. So showing the common interface, the real simplified interface of the acquisition modules, alongside the sort of real-time visualization of the geographical context in the Delph roadmap module. That's useful, Philippe. So now we want to move on from there and put that acquisition side of life to one side and focus on the sort of the business end of things and get into the interpretation and the QC elements. Just give us a quick snapshot again of the modules concerned there, Philippe, and then we'll run into a series of short movies which demonstrate each sensor data and how that can be handled.
Okay, so getting out of the survey data collection operations, we now have some raw data recorded, or it can come from any recording system as soon as it's standard industry format in there. The data will reach the Delph interpretation software package. We will first go into the very fine-tuning of the data processing within the dedicated modules, or SASCAN, seismic, and MAG. And then we will see how to use the very optimized workflow in Delph to quickly achieve results, process data, cartography results, the maps, and how the roadmap software can help you also in a global understanding and global QC of the survey. So we will show you some sample projects. The first project right now is the SASCAN data processing. So we briefly saw the roadmap software in which we see track plots and coverage displaying. So this is where we bring the raw records. And we have this user interface, which is very intuitive to tune the gains and the processing settings for the sonar records, to apply them to the file, so to get the best results out of the data records. We can optimize the gains, we can fine-tune the bottom tracking, etc. So that's a good QC level of the individual records, let's say. This is also the place when we will save these tuning processings, and then we can further write to the complete data sets. We will see that in the second chapter. Right now on screen, it's some target picking out of the waterfall. So if you want to do systematic target picking out of the sonars, either you can just create them and they will open in the analysis environment. We are helping users providing automatic measurement of the targets. We detect the echo shadows and decline the measurements. So to save a lot of manual operations in there. But you can also just flag the targets on the waterfall. So what you will see in a few seconds, just picking some targets. And then we have all the targets appearing in the catalog, which is the target manager. to have an overview of the target database, to do filtering, sorting, intuitive drag and drop of the targets to the categories, etc. So something, again, helping a lot the manual operations. By the time you are working, the map is being built, so we can see now all the targets which have been created directly on the map, combined with all the other data information. We will see an example for the mosaic in the second stage, but right now this was a quick presentation of the user interface for processing and do the fine-tuning of the side scan sonar data processing.
Okay, excellent, Philippe. Thanks for that. As I say, it's a whistle-stop tour through the software, and hopefully you're picking up some ideas of some of the features which can bring efficiency and speed to the operations here. And now, if we move on to the next topic, being the sub-bottom profiler data, and hopefully you'll see some of the common elements in the interface and so on, and you'll see once again the data visualized in the Delph roadmap software initially. Let's have a look at that, Philippe.
Yeah, so you will see a second project. We start from the same roadmap software, so this is not individual software, it's all working with the same core parts. So now within the roadmap software, what we see is the track plots and the georeferenced sub-bottom sections. So this is something we provide like we do the sonar mosaicing. So we create very quickly these 3D fence diagrams. You can import external data like core logs that you can bring and overlay onto the 3D, but also onto the sub-bottom profile, so to correlate the reflector interpretation together with the ground truthing data. We see the bottom window, which is the processing window. So this is where we are picking reflectors, but also the place for tuning, gains, filterings, all kinds of processing that apply to sub-bottom profiler data or reflection seismic data. And once we have the data processed, so we can directly map it, like you see now, we have a complete view of the sub-bottom profiler project. We can see all the connections between the profiles, vertical corrections, and also a 3D view of your sub-bottom interpretation. So you can check the global consistency of your sub-bottom interpretation.
That's great, Philippe. Excellent. And now we're going to move on and we're going to look at some MAGI data. And I think this is maybe the first occasion where we start to sort of see some blended data, which starts revealing the power of this 3D visualization of combined data sets in one environment.
Yeah, right. So let's see the next project for the magnetometer. You will see in this video, so that we have, again, the same mapping software integrating more sensors. We can see the magnetic data first being plotted like a wiggle vector line. So we can see the track plot. We can see the anomaly as a vertical vector line. We use the vertical dimension for that. And very quickly, we can do the filtering and the mapping of the magnetic anomalies, magnetic anomaly, gradient, and so on, create different surfaces that will help it to locate all the potential hazards in the survey field. So this creates this surface. We can directly use the transparency features and the combination of all the layers in the project to combine the MAG together with the bathymetry, to combine it with the side scan, to combine it with the sub-bottom profiler. And again, to save time in the operation, so we can directly spot the magnetic anomalies out of the map and zoom into those anomalies and look at the layers behind, so we can see the side scan mosaics behind of it. So if there is any hazard, is it at the surface of the seabed? So like in this case, we have a big anomaly, and from the side scan, we can directly spot the wreck being displayed right now on screen. So this is how the MAG can be quickly processed and very efficiently drive your interpretation of the side scan records. If it was not at the surface, maybe the sub-bottom profiler in the 3D view can help you reveal some buried features. This second example is a very small thin cable which is down on the ground. And again, just zooming into the magnetic anomalies will quickly reveal the features from the larger scale high-resolution side scan mosaics or sub-bottom features. So that's already some good combination of the different sensors because all the data is georeferenced, and we take benefits of this georeferencing in this 3D visualization.
Again, that's excellent, Philippe. Thanks for that short video. It's excellent to see it all coming together. So moving on from there, so we can see the power of the 3D visualization, multi-sensor data. And I think the next thing we want to focus on is now looking at mosaicing and batch processing and the efficiencies that we can bring to the operation from those modules.
Yeah, that's one of the key facts in the Delph software is really to focus on an efficient workflow. Make sure that the geophysicists don't spend days and days in tweaking buttons and windows and to process the data in long time. So to achieve the results much faster, we want to reduce all these manual operations. This means like fine-tuning of the processing settings on a few records out of the side-scan survey. In this case, we have some example of a wind farm project with a complete side-scan coverage. And so we will use the fine-tuning. We decided on a few samples to apply it to the complete data set. So right now, it's of course a bit exaggerated, but you have the timing on the bottom right. We are processing this 180 records of side-scan data in about a little less than 9 minutes, I guess. So very quickly, directly reading from the raw data using this standard format, achieving the process results. And now the complete survey has been processed in just, less than 10 minutes. Out of there, we do additional QC steps, of course, and we can run directly the mosaicing stage. So we will decide the resolutions, the strategy, etc. But we will directly create the mosaics also in a very efficient way, directly saving the mosaics into a standard geotiff data format. So there is no further export required. And we directly have the high resolution. It's a 10 centimeters mosaic in this case, being achieved in just a few minutes. It's a little less than 10 minutes in this example, which means a total processing time of roughly 20 minutes for this complete side-scan data set, which is quite fast, of course. And anytime you can reprocess, you can improve the data, reprocess a complete data set in just a few minutes. Now that we have the data ready, we see right now is the high frequency mosaic alternate with the low frequency mosaics. With the transparency features in the map, you can directly switch in between the high and low frequency. So inspect the features, seabed classification, and seabed features. So right now is a few zooms on such areas. And then this is the same environment in which you can do further seabed classification, contouring of the seabed faces, and also do the target picking. So we've seen the first example of target picking from within the sonar waterfall, but we can also process to the target picking directly from the map. As soon as we see the targets on the mosaics, we can flag them, create the targets, and then we also add to the target catalog, which is now displaying on the right-hand side. So we create targets, and the targets get logged. We see them in the catalog. And directly from there, once the targets are created, we can further inspect, measure, classify the targets. So as previously said, we can help the users a lot in saving time. So you can just flag all the targets very quickly without waiting for windows to open and so on. Further on, focus on the interpretation of targets. In there, the software is saving a lot of time by directly computing the measurements from targets, deleting target echoes, shadows, etc. So to reduce, again, all the manual operations in all the measurement that can be done on the field.
That's great, Philippe. Thanks for that. So there's a little snapshot of the power of the batch processing and mosaicing functionality, and a little snapshot on the interpretation of some sonar data. Now, we touched on it a bit earlier, and we saw some samples of some kind of combined data sets, multi-sensor data sets, Philippe. And I know that you've got another example from L'Arve of a multi-sensor data set, which reveals quite a lot of interesting features of the software as well.
Yes, exactly. So we will see a next project in which we are combining a few sensors. This was a survey in the harbor of Le Havre in the previous conference last year. So we can see already background information like aerial photography of the harbor, integration of the multi-beam bathymetry, which has been acquired during this survey. And we are now looking at the sub-bottom sections, which have been collected by the sub-bottom profiler. So we've been using a pole-mounted high-resolution sub-bottom profiler, which is the ECOS 10,000, which has been presented in an earlier webinar and which is on stage together with you. We see also the 3D interpretation right now of the sub-bottom sections. So we did the picking of the reflectors, and they will all appear in the 3D map, so we can check consistency and all the necessary vertical corrections. Further on, now we are adding the side scan information. So we are overlaying the bathymetry with the side scan mosaics. And this is very helpful because we can already combine not only the high resolution aspect from the side scan, but also the relief from the bathymetry. So this is already a good QC about the target location, if the positioning was done right, and also helps revealing all the bumps and holes, the real topography of the seabed features we see in the side scan. So here is a small object, so we can see the bump on the bathymetry, but not so high resolution, together with the very high resolution side scan imagery. Also, we have this kind of trench, which is there in the harbor, so we can combine bathymetric and side scan. We can see the detailed shadows and topography, but also we can see the perturbation of the superficial sediment directly in the sub-bottom sections. So watching all the sub-bottom sections in 3D helps connecting this perturbation throughout the records and combining them with the topography and the high-resolution imagery. So this is a good example on how to assemble the complete data set and not only do the nice images, but this is really helpful for a global and accurate understanding of the survey from QC to interpretation. And this is really the tool that you can work on during the geophysical data analysis. So here is now the complete overview with these different data sets. So now you have a better overview of how to combine all this information, provided that you have, of course, a good positioning solution and high definition sensors.
That's excellent, Philippe. Thanks for that. So there's a really good example of the power of bringing everything into the one environment in Delph Roadmap to visualize quickly the characteristics of each data set. And as you say, relying on good navigation to georeference each of the sensor types. So that's it for our of the main videos on the processing or the interpretation modules. I think, you know, it's about the formats, it's about the common workflow and the batch processing and the efficiencies coming from all of that, Philippe, and the multi-sensor integration. Let's have a little think now about the real-time processing, because I know that's a feature of the software which is really, really powerful, especially in this age of the proliferation of unmanned or uncrewed survey platforms, and how to deal with that, you know, revolution in an efficient manner.
Yeah, for the very first years of the Delph software, we've always been striving to provide real-time data processing already for CNAC capabilities on board the survey vessels, to be able to directly spot hazards and to re-inspect information while still on the field without waiting for any post-processing in the office. And this is something we've pushed further, so to be able to automate data processing, data mapping on any embedded computer, so to be able directly within the computers on board crewed vessels, but also AUVs or USVs, be able to do the necessary steps of data processing, data mapping, so the maps are available directly on board these vehicles. This also provides an immediate availability for data for QC, so meaning that when the vehicle comes back, you can directly look at the process records and maps, so the QC can start instantly without waiting for all these initial stages of data processing. So on the field, you can quickly also on a crewed vessel plan directly coil location, grab sampling, etc., because all the information appears georeferenced. Same thing, if you see some buried features on the sub-bottom, you can spot them and re-inspect them or do closer, shorter line spacing to inspect them. So we've seen on screen just before some real-time sub-bottom processing. Now it's real-time side scan mapping on top of the bathymetry. So as soon as we start logging the data, we start processing records and building the mosaic, so we can complete the real coverage of the data, and we can further inspect the real-time map. So here is the side scan mosaic being built. Soon it should come onto some rec in this survey. So we can directly see not only in the real-time waterfall, but also directly from the maps where the features are located. So now we can see that rec, so we can closely inspect. We have the high definition mosaics already available, standard formats, like always. And we can already combine it together with the other sensors to confirm whether it's been seen on the bathymetry, on the magnetometer, etc. So we have a good confirmation in real time.
That's excellent, Philippe. I think it's good to get a snapshot on that and to get an understanding that the software from the very outset was built with the goal of creating a solution to process in real time. So really just focusing on shortening that time to the end result across all the sensor types. That's good. Okay, so now we've come to the end of roughly to the end of our presentation. Hopefully we've kind of whetted your appetite. We've sparked your imagination as to how this software might bring some efficiencies to your own operation. If you want to know more, then don't hesitate to contact us, and Philippe and his team will be really happy to engage in a dialogue on your specific data or your specific sensor integration or sensor type. As I said earlier, we're planning to do more webinars in this series, and I think that the two that we're looking at doing are looking at the interpretation and processing of side scan and MAGI data in one event, and then in a second event with seismic and subaltern profiler data. And let us know. You vote. You tell us which one you'd like to see first, and we'll react accordingly. Yeah. So Philippe, we've got some questions, but I mean, I think just in summing up, the key takeaways are, the multi-sensor 3D environment, the batch processing, the efficiency coming from the real-time functionality, real-time processing. Did I miss anything?
Yeah, no, I would summarize, I would say that the first stage is to ensure that you have a proper data collection with good sensors, good positioning, make the raw data very raw so we can do the best processing out of it. And then is really all this time-saving workflow. So it's having a very good understanding of how operations are done, save time and manual operations to the geophysicist using the aiding functions like automatic target measurement and so on. Provide all the data, high resolution, directly in standard formats that users can further use in CAD software or GIS software. So we are ready to go when you do the processing of the data. You have quickly the data to work on, and you save time for further interpretation, which is really the geophysical work rather than just buttons, I would say. So yeah, we are keen to demonstrate, study existing customers' workflow, see how Delph can help improving your life. So yeah, more than happy to do further demonstration. Yeah.
Excellent. Well, we've now got some questions, Philippe. So I hope you're sitting comfortably. Yeah. First question. Does the software, or will the software, have automated filters to avoid manual boulder picking in the side scan sonar or multi-beam echo sounder data?
That's part of the fields we are working on. Today, the results are not in production, but that's really something we've been working on and starting to have good results about it. And it's not only about boulder picking, but to have to determine everything that is getting out of the data set. I would say non-natural, so it can be sparse objects, it can be located objects, individual objects. So that's something we are working on, but it will take a little more time to achieve this. Already saving all these manual boulder measurements, meaning just picking them, but they will get automatically measured. You can directly filter them by size, length, height, etc., and to automatically bring them into the right categories is already some feature that saves a lot of time. We know we won't replace the human completely, so it's good to provide this level of QC and adding function. So we are working on that. The intent is not to create thousands of wrong targets. We prefer to really work on what would be efficient in a real life workflow. Okay, so we do we've got some automatic features in terms of target classification or measure dimensioning. There's a plan to increase the target picking and to automate that in the roadmap, as it were. But we're going step by step. We don't want to, let's say, go too far before we really trust the functionality. Exactly. Okay, another question. Can you plan your navigation in Delph Acquisition? So the planning of the lines can be done within the roadmap software. You can input coordinates, or if you already did some line planning. So that's some information you can add as layers or create the lines from within the roadmap software. Also to notice that it's not meant to be a navigation software. Okay, we are still working in the geophysical field, so this is geophysical data collection software. But you can import any line planning and monitor your trajectories, your location on this line planning here.
Yeah. Okay. Yeah. So it's not designed to be a navigation suite, which leads up quite nicely to this next question, actually, Philippe, which is, can you add data layers in your mosaic, cables, areas, etc., coming from formats such as shape files or DWG files?
Yeah. So the Delph software is completely open to standard GIS formats, so you can import any data from DXF, shapefiles, GML, KML, etc. So we support all of these formats. You can also import them as for further drawing of these. So you can import them as the graphical annotations. You can then modify, and you can also design by yourself any features, contour features, draw pipes and cable locations, etc. And this can also all be saved in these same standard formats. DXF, shapefiles, etc. So back and forth, we can use these standard formats here.
Yeah. Okay. Yeah. There's another one in the same sort of vein. I see you can display dynamic maps. Can you also make static charts maps?
Not know if I completely understand this one, but yeah, we have this 3D dynamic visualization of the data set, which is aimed to be a tool for understanding the data set, to QC and to do the interpretation, which is really the geophysical work. If it's the question of producing, I would say, the paper charts in the end, no, that's not in the scope of the Delph software. The aim is to prepare the data from geophysical sensors to GIS formats, and then to use regular GIS platforms that everyone is using with already the proper scale bars, etc., that you are using on a daily basis. So we want to provide the GIS data faster, so you can use it directly.
Yeah. Okay. Sure. There's another one about the roadmap module. So does the roadmap module come with Delph acquisition license, or does it come together with the interpretation license?
Okay. So the Delph roadmap software is a product that can be used standalone for navigation purpose. So if you can use it with the Delph acquisition software, just downloading the roadmap, and it will connect to the acquisition to directly plot the trajectories. So even if you don't have the full Delph interpretation package, and then of course, if you are installing the Delph interpretation package, you will get also the Delph roadmap installed because it's really at the heart of the processing suite. Yeah.
So the Delph roadmap module is available to anybody and everybody. Really, it's a part of it's the core part of all of the modules. So we've got another question here, which is coming. It's about interpreted reflectors. So are detected and interpreted reflectors easily exported to other software? Kingdom, it's practical, and that's certainly the case with this software and this application. So another question: how to make sure that data processing in Delph is compatible with my existing workflow? So it's a tricky question. That I don't know where you start with that one. Let's learn a bit about your existing workflow.
Yeah, it's not so tricky because we are compatible with all these standards and very familiar formats from the industry as an input and as an output. We already implemented it in so many companies, dealing with so many acquisition software, being Delph or further OEM software. We are dealing with all kinds of GIS applications in the back, CAD softwares, and so on. So Delph has been implemented in the industry for quite a while, and we are sure that it's compatible with the most software that you are using as well.
Mm-hmm. Okay. How are we doing for questions? Have we got any more questions? Any more questions? Any more for any more? Yeah, here we go. We've got another one here. So let's just what about the modules and dongles and stuff? How can the software be acquired?
Okay.
In terms of modules and dongles and software licenses, can you just describe that quickly for us, Philippe?
Yeah, I get it. So already you've seen from the matrix that we have two main products, Delph Acquisition, Delph Interpretation, which can of course be purchased separately. So you may only get the acquisition software if you need, or you may only get the interpretation package because you already have your acquisition set up and you just want to take the full benefits of the processing suite. The licensing is quite simple because we have all these modules available in the licenses. So it can be an acquisition or processing license. And then you decide if you like to have only the SideScan or SideScan and Maggie or SideScan Maggie and Subbottom on that same license. So that's a very simple scheme depending on your needs. And we can, of course, give a proper advice about what you really need for your operations.
Okay. So we've got another quick question. Can we organize a trial session with Delph?
Yes, of course, it's possible. So we have different ways to do that. Of course, it can be just a simple trial license, temporary license for your use. So you can play with your own data and see the benefits of the software. And still, we like to improve this by organizing a dedicated webinar. So just share a couple of hours together. So to help you in starting with the Delph software, make sure you use it in the most beneficial way so you can just avoid to use it like any other software, but really take the full benefit of all the add-ons regarding all the editing functions that we covered in this webinar. Okay, well, I think that's it for questions. So hopefully that's helped everybody. And if you've got if any questions spring to mind after this, then please don't hesitate to drop us a line. Well, thank you very much, Philippe. Thanks for putting those movies together and explaining things today and answering those questions. Yeah, thank you, David. Thanks, everyone, for attending, and more than happy to push the discussion further with you anytime you like. I'll be there. Thank you.
Great. Cheers.
Cheers. Bye.
Okay, well, thank you very much, everybody, for attending this webinar this morning. I hope it's been useful. It was a tricky exercise to work out how deep to go and how far to go in terms of the software suite. Our idea was to try and spark interest in the functionalities across the full range, across the full capability of the software. And as I explained earlier, we'll be digging deeper into specific modules in later events. So look out in your calendar for those. We'll be putting a recording of this one on our website later and on YouTube. So if any colleagues could benefit from just this very quick overview, then point them in the right direction for that. In the meantime, I think just thank you very much for joining us, and we hope to see you again at another X Live. Bye.